Section 2.6, Graphs of Basic Functions. So in this section, we're going to look at continuity, as well as looking at different basic functions that we use in algebra, including a piecewise function. First of all, we're going to look at continuity. A function is continuous over an interval of its domain if its hand-drawn graph over that interval can be sketched without lifting the pencil from the paper. So pretty much there aren't any holes in the function. You can draw the graph of the function without lifting your pencil up from the paper. That would be considered continuous. Most likely every function that you can think of right now from algebra has been continuous. So here's an example. Describe the intervals of continuity for each function. So anytime we're looking at continuity or increasing, decreasing, constant, anything like that, I want you to think about tracing the graph from the left to the right. So the furthest most left point is right here. Put your finger on this and trace the graph. See how we never have to pick up our pencil or pick up our finger, and we've traced the entire graph. So this function is continuous over the entire domain. It's continuous from negative infinity to infinity. We never had to pick up our pencil. With this next function, you may notice a hole. So right here, there's an open circle. We call that a hole. So when we're drawing this graph, or if we're tracing it, we put our finger on the furthest left point, and we're tracing. At this point, we have to pick up our pencil and then put it back down to keep drawing. So I can't just draw this graph without picking my pencil up. I have to pick it up, go over that hole, and then continue on. So our solution here is we've got a point of discontinuity at x equals 3. So we're continuous over the interval of negative infinity all the way to 3, and then 3 to positive infinity. So pretty much we're continuous everywhere except for at 3. Now we're going to look at a few functions that we use in algebra. This first function, f of x equals x, is just a linear function. Another name for it is the identity function. Our domain, which is our x values that's spanned by the graph, is negative infinity to infinity, because this arrow forever goes to the left and this arrow forever goes to the right. So it's going to cover all of the x-axis. Our range is also negative infinity to infinity because this arrow goes down forever, this arrow goes up forever, so it covers all of the y-axis. You see here we have a table of points. Anytime you need to graph a function, just plug in some numbers for x into the function and you'll get out your y coordinates. This graph is increasing on the interval from negative infinity to infinity because when we trace it from the left to the right, we're increasing the entire time. It's also continuous on the entire domain because there are no holes. We don't have to pick up our pencil at any point when graphing. This next function is a quadratic, or another name for it is squaring function. F of x equals x squared. The domain is negative infinity to infinity because these arrows are forever going to the left and forever going to the right. Even though it looks like they're going straight up, they're still going left and right as they move. And then our range is from 0 to infinity. Our lowest point on the graph is right here at 0, and then it goes up. So our y values go from 0 to infinity. We're decreasing on the interval from negative infinity to 0. As we trace, we're going down. As we trace from the left to the right, all the way to 0. And then we're increasing from 0 to infinity. So now we're going up. Also, this graph is continuous on the entire domain because we can draw it without picking our pencil up. There are no holes. Here's a table of values. Anytime you need to graph a quadratic, just plug some numbers in for x and you'll get out numbers for y, and that should give you points along the graph. Our next function is the cubic function. This is f of x equals x to the third. Our domain is going to be negative infinity to infinity because my arrows are forever going left, right. My range is negative infinity to infinity because they're also forever going up and down. We are increasing the entire time. If we start on this furthest left point and trace the graph, we're going up the entire time. And we're also continuous on the entire domain. Our next function is the square root function. This is f of x equals square root of x. The domain is from 0 to infinity. My graph starts right here at the origin and then goes to the right. Whoops. So it covers all of this part of the x-axis. And my range is 0 to infinity as well because my lowest point is right here again, and my graph is moving up, so it goes up to infinity. We're increasing the entire time, and we are also continuous. At no point do you have to pick up your pencil when drawing the graph. The cube root function looks like this. Again, domain and range in negative infinity to infinity. We're increasing the entire time and continuous. The absolute value function, absolute value of x. Domain is negative infinity to infinity because those arrows are forever reaching to the left and the right. And the range is 0 to infinity. Our lowest point is at 0 on the y-axis, and then it just goes up from there. We're decreasing on the left, so negative infinity all the way to 0. And then we're increasing on the right, 0 to infinity. Continuous on the entire domain because as you draw this, you never have to pick up your pencil. Next, we're going to look at piecewise functions. So the way we can think about piecewise functions is we're taking pieces of multiple functions and putting them on the same graph. So here I have two functions. One of them is negative 2x plus 5, and I'm going to graph that everywhere that x is less than or equal to 2. I also have the function x plus 1. I'm going to graph that everywhere that x is greater than 2. So to kind of think about that visually, 2 is my breaking point here on the x-axis. By the way, don't draw this, I'm just giving you a visual. So the first function, negative 2x plus 5, I'm going to graph it on this side. And then the second function of x plus 1 is going to be graphed on this side. So let's start with the first function, negative 2x plus 5. I'm going to graph this in red. So what I'm going to do is I'm going to plug in 2, since it says x is less than or equal to, and I'm going to get out a point. So that's going to be 1 point on my function. Then I'm going to plug in 1, because I'm looking again for x values that are less than or equal to 2. I'm going to plug that in and get another point. And let's go ahead and plug in 0 and get a third point. Now we can graph these 3 points on our graph and stick an arrow on the left end since I'm looking for all x values less than or equal to 2. So one more time, I chose these numbers because they were less than or equal to 2. Next, I will graph the other function in green. I accidentally erased my red function. It will come back here in a minute. So what we're doing now is we're going to plug in 2 and bigger for x's. Whenever I plug in 2, I'm going to have a hole at this point. The reason I have a hole is because for this function, my domain is x is greater than 2. So I want everything bigger than 2. We'll just have a hole right here. So then now let's plug in 3, get another point. We'll plug in 4. And now we can graph these. So let me put my red graph back on here. I accidentally erased it. You'll notice that I have a hole for that point, 2, 3. Again, the reason why is because the domain of this part of the function is x is greater than 2. So I want everything greater than 2, and just have a hole right there. With this next piecewise graph, I notice that my first function, 2x plus 3, is going to be a linear function, so a straight line. But my second function, I notice, will be a quadratic, so it should be curved. Let's start with the first one. We're going to graph the function 2x plus 3 when x is less than or equal to 0. So let's start by plugging 0 into the function. And we will get the point 0, 3. We'll also plug in -1 and -2. And we can plot these 3 points. Notice that the point 0, 3 has a closed dot on it. The reason I picked a closed dot and not an open dot is because our problem says x is less than or equal to 0. My other function, the -x squared plus 6, will have the open circle. All right, the next part of this function I'm going to graph in green. And remember, this is going to be a quadratic, so it should look like a curved graph. Remember, quadratics look like a U. We'll only have part of it, though. So I'm going to start by plugging in 0, and I'm going to have a hole at this point, since my domain says x is greater than 0, and it doesn't have the or equal to sign. So this will be a hole. And now I'm going to plug in 1, 2, and 3 to get some more points. And there's my part of the parabola. Remember, I chose to plug 0, 1, 2, and 3 in because my domain for this part was x is greater than 0. Numbers that are greater than 0 are 1, 2, and 3. On this last problem, I just want to talk about the domain and the range of a piecewise function. So domain, we're looking at our x values here, and we're looking at everywhere that's covered by the graph. So let's start with our furthest left point on the graph, which is over here. And it's got an arrow, so I know it goes to infinity. Our graph is covering all of these parts of the x-axis, and then we hop up to the next part, it's covering all of the x-axis. So our domain is -infinity to infinity. Our range is going to be a little bit different. Again, it's going all the way to -infinity because it's going down. So we're covering all this part of the y-axis, and we stop at -1. So we've got -infinity up to -1 with a bracket. And then we kind of just skip all of this part of the y-axis. So none of that is in our range. And then likewise, we don't have any of this in our range. So we have -infinity to -1 bracket union just the number 2, since we have our graph going through 2 on the y-axis.